Let's take a look at these examples of questions on integers and number theory. Now these are questions that will assist you in answering the assignments on integers and number theory. Right? That assignment applies to students of mine. Here, write down all the prime numbers up to 10. Well, of course, prime numbers are those numbers that are divisible only by themselves and 1. So, you can divide a prime number by 1, you get back the number. Divide it by itself, you get 1 as the answer. But any other number you try, you will get a fraction or some remainder, right? You only divide it by itself and 1 without getting a remainder. So let's see what happens here. Write down all the prime numbers up to 10. Well, 2 is the smallest prime number. It's also the only prime number that is even. You have 3, 5. If you try 6, 6 can be divided by 2 and also 3, so it's not a prime number. 7, okay. What about 8? Well, 8 you can divide by 4. You get an answer without a remainder. You can also divide by 2, so it's not a prime number. If you try 9, you can divide 9 by 3 without getting a remainder. 10, well, it seems 2, 3, 5, and 7 are the only prime numbers you have here. Now here, write down the prime factors of 3. Well, let's make it 30. Prime factors of 30. Those are factors of 30 that are prime numbers. 2 can divide by 30 without leaving a remainder, so 2 is one of them. 3 into 30 is 10 times. No remainder, so 3 is one of them. 5 can divide into 30 to get 6, so 5 is another. 7, no, you can't divide 7 into 30 directly. What's the next prime number now? 11 can't work. 11 cannot divide into 30 directly without leaving a remainder. 12 is not a prime number. 13, yeah, 13 is a prime number, but it doesn't divide directly into 30. 14, 15, 16. Well, once you pass half of 30, once you pass 15, no, nothing else works. Right? Because even though 17 is a prime number, you cannot divide it into 30. You don't have 2 or more 17s into 30. So 2, 3, and 5 are the only numbers here. Illustrate the following on a number line. Let's see how this would work. The number line. So you have a number line here, and you have 0, 1, 2, and so on and so forth. Negative 1, negative 2. Alright. You are at 1. Good. So you have 3, 4, 5, 6 is here. Now, the square bracket means that 1 is included. So you shade the circle above 1. Right? The square bracket included. One way I remember that is to have a square bracket, and then it kind of looks like I for included. I. Alright, so this looks, you can turn it into an I here. So here now, the round bracket you have not included. That's a round bracket. 6 is not included. Alright? So the interval would be these two. So the numbers that you have here would be 1, 2, 3, 4, 5. You don't call 6 because 6 is not included. So this is how you would illustrate it on a number line. Alright, let's erase some of these things to make space. Now this is the one we're looking at now. Here we have 16 squared minus 25. 16x squared minus 25 are supposed to you're supposed to factorize that. Now we have 16x squared minus 25 here. If you look at this, right? Oh, there's nothing to factorize here. What I should have had is 5x squared minus 25. That's what I was thinking about. Or if I had 5x squared minus 25 here, or better yet, not 5x squared minus 25. Suppose in this case I had, well, it could work anyway. Let's go on with it. I was thinking of something different from this, but let's continue with this. 16x squared minus 25. What we have here is called the difference of two squares. There's a square on the left, there's a square on the right, and the subtraction means the difference. So here now, what is it that you must square to get 16x squared? Well, here what you must square is 4, and here what you must square is x. What is it that you must square to get 25? It's going to be 5. Now, what you're going to do as a shortcut here, you could use the AC method to factorize it because it is a quadratic expression. But as a shortcut, you're going to have two brackets multiplied, a plus and a minus, one and the other. Here now, what you have on the left, you must write down whatever it is that you square to get it on the left of each bracket. So what is it that you must square to get 16? You must square 4. So it's 4 on the left of each bracket. What is it that you must square to get x? It is x that you must square. On the right here, what is it that you must square to get 25? It is 5 that you must square. So what you have is 4x plus 5, 4x minus 5. That's the answer. You could test it a bit. Suppose, let's say you have 4x plus 5 and 4x minus 5. 4x times 4x gives you 16x squared. 4x times negative 5 gives you negative 20x. 5 times 4 gives you positive 20x, and 5 times negative 5 gives you negative 25. What you will see is that negative 20 plus 20 is 0, so this is gone. So on the left you have 16x squared and minus 25 on the right. So you see that you get back the same thing when you multiply out back the brackets, alright? But anyway, let's erase these. I'm making space. Here now, you can erase this as well. The LCM of 2, 5, and 7, lowest common multiple. What's the smallest number that all of these can go into without leaving a remainder? Let's look at the biggest number here. Multiply by 2, you get 14. 2 can go into 14, but not If you say 7 by 2, you get 14. 2 can go into 14, but not 5. If you try 3, 7 times 3 gives you 21. But these can't go into 21. 7 4 is 28, 7 5, 35. If you try 35, 7 times, let's erase this. So here, 7 times 5 gives you 35. The fact is, 5 can divide into 35, but not 2. So you have to continue. 7 4 is 20. No, 7 6 is 42. 7 7 49. 7 8 56. 7 9 64. 7 10 70. Alright. 7 times 10 gives you 70. 7 can go into 70, yeah? Can divide into 70. Can 5 divide into 70? Of course. Once the number ends with a 0, 5 can divide into it. What about 2? Can 2 divide into 70? Oh yes. So, the fact is, 70 is a multiple of 2 because 70 divided by 2 gives you 35, no remainder. 70 is a multiple of 5 because 70 divided by 5 gives you 7, 5, 12, 6, 5. Okay, so 5 into 5, 1, 5 into 7, 1 time 1, 2, 5 into 24. It goes 14, no remainder. Good. So 70 is a multiple of 2, it is a multiple of 5, and 7 into 70 goes 10 times, so it is a multiple of 7. It is a common factor. It's common throughout here. I mean, it's a common multiple of each of these numbers. It is common throughout. So else the lowest common multiple of 2, 5, and 7 is 70. So the answer here is 70. 140 could work, but it's not the lowest. The lowest is 70. Now, what about the highest common factor of 25, 50, and 70? Alright. Now, 25 is a factor of itself and also a factor of 50 because it can divide into 50, but it's not a factor of 70. Alright. What else can divide into 25 and 50? Let's see. What else can divide into 25? 5 can go into 25. Good. Without leaving a remainder. Can 5 go into 50 without leaving a remainder? Yes. Can 5 go into 70 without leaving a remainder? Yes. Alright, so 5 is the highest common factor of 25, 50, and 70. So that assignment which I mentioned earlier, so you work through it. Hopefully this will help you to work through that assignment.